Hello students, let us begin the session on revision in the chapter circles. We'll first look at the main concepts in the chapter. The main concepts and the results are the meaning of tangent and its point of contact on a circle. Second, tangent is perpendicular to the radius through the point of contact. The third, only two tangents can be drawn to a circle from an external point. Fourth, length of the tangents from an external point to the circle are equal. We shall look at exercise questions and use these concepts in solving them. First question here is to choose the correct answer from the given four options. If radii of two concentric circles are 4 cm and 5 cm, then the length of each chord of one circle which is tangent to another circle is. So we need to find out the length of the chord which is a tangent to the smaller circle. The convenient diagram I have taken here. Here we have got two circles named as C1 and C2. C1 is the smaller circle with the radius 4 cm. C2 the larger circle with the radius 5 cm. Let O be the center for both the circles. Here, if you observe it very carefully, the radius OP is perpendicular to the chord which is the tangent to the smaller circle. We all know that the chord which is there inside and a perpendicular is drawn will bisect the chord. So we'll have the result AP equal to PB. This will be equal to AB by 2. You observe we have got a right angle triangle here. In triangle OAP, Pythagoras theorem says the square and the hypotenuse OA square will be equal to OP square plus AP square. Here OB square, OA square is 5 square which is equal to 4 square plus AP square. Let's find out the length of AP. So AP square will be equal to 5 square which is 25 minus 4 square which is 16. We get the difference as 9. So the length of AP is 3 cm. They have asked us to find out the length of each chord of one circle which is tangent to the other circle. So the length of AP is 3 cm. Therefore, the length of AB will be 2 times AP because it's there in this result. So it is 2 times of 3 cm which is 6 cm. Hence the right answer is 6 cm, option B. Second question. In the figure 9.3, if angle AOB equal to 125 degree, then angle COD is equal to what? We know that a quadrilateral circumscribing a circle subtends supplementary angles at the center. So angle AOB plus angle COD will be equal to 180 degrees. So 125 degree plus angle COD equal to 180 degrees. Angle COD will become equal to 55 degree. Hence the right answer is option D. We have used the result that A quadrilateral circumscribing a circle subtends supplementary angles at the center of the circle. Question 3. In the figure 9.4, AB is carved off a circle and AOC is its diameter such that angle ACB equal to 50 degrees. If AT is the tangent to the circle at the point A, then angle BAT is equal to what? Observe the figure carefully. AC is the diameter. AC is diameter. Therefore, it subtends angle ABC at circumference, which makes 90 degree, because angle in a semicircle. Therefore, we have angle sum property says that angle BAC will be equal to 180 degree minus the sum of the angles 50 plus 90. So the remaining angle will be 40 degrees. Now we know that tangent AT at A and radius OA at A makes 90 degree. That means angle OAT is 90 degree. What is angle OAT? It's a combination of angle OAB plus the angle BAT. Therefore, angle BAT will be equal to 90 degree minus the angle OAB. Angle OAB is same as angle CAB or BAC. So it is 90 minus 40 degree, which is 50 degree. So the right answer is option C, 50 degrees. Question 4. From a point P which is equidistant, which is at a distance of 13 centimeter from center O of a circle of radius 5 centimeter, pair of tangents PQ and PR to the circle are drawn, then area of the quadrilateral PQR is. Let's take up a figure suitable. In this figure we have O is the center of the circle, OP is the distance from the center to an external point. From there we have got two tangents PQ and PR. The length of the tangent will be 12. Why it is 12? The reason is it forms a right-angled triangle. Since OQ is perpendicular to the tangent PQ, the radius perpendicular to tangent, we have Pythagoras theorem used here. The length of PQ will be equal to the square of PQ will be equal to OP square, which is hypotenuse square, minus the other side. So this implies that PQ is root of 13 square minus 5 square, which will be root of 13 plus 5 into 13 minus 5. 13 minus 5 is 8, and 13 plus 5 is 18. So it is root of 144, which is 12. So we have the length of PQ, which will be equal to the length of PR. This will be equal to 12 centimeters. Now to find area of the quadrilateral, we require the area of these two triangles here. You observe carefully, we have got equal sides, a common side, and another side is equal. So I can state that the triangle PRO is congruent to the triangle PQO by SSS criteria of congruency. So area of quadrilateral will be equal to twice the area of one of the triangle, say PRO. What is the area of the triangle PRO? It is half into base into height. In this case, the base will be the length of the tangent, which is PQ or PR, here PR, into the altitude. Altitude is the radius, OR. So half and half will get cancelled. We'll be getting 12 times 5, which is 60 centimeters square. And this is present in option A. This verifies option A is the right answer. Question number 5. At one end A of diameter AB of circle of radius 5 centimeter, tangent XAY is drawn to the circle. The length of the chord CD parallel to XY and at a distance 8 centimeter from A is. So we need to find out the length of the chord here. Let me draw a suitable figure. In this figure you can observe XAY is a tangent and CD is drawn parallel at a distance 8 centimeter, and the radius of the circle is 5 centimeter. Since radius is perpendicular to the tangent, the angle so formed here is 90 degrees. Since CD is drawn parallel to XAY, angle OMD will become equal to 90 degrees. The reason is angle OAX, which is equal to angle OAY, this will be equal to 90 degrees since radius is perpendicular to tangent. Since the interior angles towards the same side are supplementary, angle OMD has become equal to 90 degrees. Here the length of OD is equal to the radius, so we can find the length of OM. The length of OM will be equal to the length of AM minus the length of OA. This will be 8 minus 5, which is 3 centimeters. Now we can find out the length of MD. So square on MD will be equal to OD square minus OM square. This is equal to 5 square minus 3 square, which will be 9. This implies that the length of, it is 16, not 9. 25 minus 9 is 16. So the length of MD is 4 centimeters. Since the length of MD is 4 centimeter, the length of CD will be equal to twice MD. This will be equal to 8 centimeter. The reason is perpendicular from center to the chord bisects the chord. So the length of CD will be equal to 2 times MD. So the right answer is option D, 8 centimeters. Question number 6. In figure 9.5, AT is tangent to the circle with center O such that the length of OT is 4 centimeters. Angle OTA is 30 degrees. Then AT is equal to. To find that, let me consider the radius here. Let me join OA, which becomes perpendicular to the tangent. We all know that while joining OA, we got OA perpendicular to the tangent AT because radius is perpendicular to tangent. So we have angle OAT equal to 90 degrees. The length of OT is known, which is 4 centimeters. Now we know a trigonometric relation which connects the sides here. If I consider cos of 30 degree, this will be equal to the base upon the hypotenuse. Here the adjacent side is the base, adjacent side is 80, hypotenuse is 4, and the length of AT we can find as 4 times cos 30 degrees. So this will be 4 times root 3 by 2. The value of cos 30 is root 3 by 2. This will be 2 times. So 2 root 3 centimeters. So the option C is the right answer. Question number 7. In the figure 9.6, if O is the center of the circle, PQ is a chord and tangent PR at P makes an angle of 50 degrees with PQ, then angle POQ is equal to. You just observe OP is the radius. The length of OP is radius. So radius OP is perpendicular to the tangent PR. This implies angle OPR is equal to 90 degrees. This angle OPR is 90 is a combination of OPQ plus 50, which implies that angle OPQ plus 50 degrees equal to 90 degrees. Therefore, angle OPQ will become equal to 40 degrees. Now let's take up the triangle OPQ. In this triangle, we have OP and OQ equal radii. Since the sides of the triangle are equal, the angles will be equal. Angle OQP will become equal to angle OPQ. This will be equal to 40 degree because angles of isosceles triangle, the angles opposite equal sides are equal. Therefore, we can find the angle OPQ now by using angle sum property. Therefore, angle POQ will be the 180 degree minus the sum of OQP plus OPQ. Let's substitute. This will be 180 minus 40 degree minus 40 degree. We get it as 100 degrees. So the angle POQ is 100 degrees. This verifies that option A is a right answer. I shall give this question for you to solve on your own. We shall discuss this answer in the next session. The question here is, in the figure, if PA and PB are tangents, to the circle with the center O such that angle APB is 50 degrees, then angle OAB is equal to, I'll be telling you the answer, angle OAB will be 25 degrees. This will be the answer. I want you to verify that. Verify answer A to be the correct answer. With this question, I'll end today's session. That's all for today's session. Thank you.